Types of hybridization. For clarity, I will use carbon atom and the three main types of hybridization so that you understand it. There are three types of hybridization. sp3 hybridization, we have sp2 hybridization, and we have sp hybridization. So let's go. sp3. What does it mean? S combining with p. To start with, carbon atom has 6 electrons, right? So in the electronic configuration, first shell, which is 1, has s orbital, and that s orbital has 2 electrons. Second shell, which is 2, has s orbital, which contains 2 electrons. We now have 4, remaining 2. Second shell has p orbital that has the 2 electrons. This is the electronic configuration. Now, the orbital diagram is represented thus. We are going to ignore this first shell because the last shell is the valence shell where hybridization occurs. So 2s2 is represented like this. This is 2s2. This is 2, the s orbital having 2 electrons. 2p2, p orbital is 3 in 1. 3 in 1. But there are 2 electrons available. You fill them this way singly to obey Ohm's rule. Now, this state is called ground state. The carbon atom is in ground state because all the electrons are at the appropriate orbital. Now, carbon forms 4 bonds around it and not 2 bonds. If you look at it, it's as if carbon uses these 2 electrons to bond with other atoms, but it is 4. Why? There is what is called promotion. One of these s orbital electron is promoted to the empty orbital of p here. Remember, this is 2p2. It is promoted, and we get another state called excited state, where we have s orbital having one electron. One has been promoted here, and this is a kind of p orbital we get. Single, single, single. This state is called excited state because one electron has jumped from lower energy to higher energy. It is called excitation. Now, after the excitation, hybridization will occur. Hybridization, where these orbitals will now mix to form new orbitals. Remember, this is s and this is p, and the shape of s is spherical. Shape of p is like this. So when they hybridize, you get something like this. You know, this resembles both this and the s orbital, sp. This is going to be sp, but we don't know how many p orbital is. So when they mix, we have this. If they mix like this, such that this s mixes with the 3 available p, we are going to have 4 new orbitals. 1, 2, 3, 4. Each of them is called sp3. Each of them is sp3. sp3. Why sp3? Because when you mix these two, this s will also show its character. The 3p will show its character. But at the end of the day, we have the character of these sp3 hybrid orbitals will be more of p because p is more in number. sp3. S is 1. P is 3 in number, right? S is 1. 1 orbital. 3 orbitals. So it's 1 plus 3 that gave you 4. So S is 1 out of this 4 times 100. That is 25% S character. This sp3 will have 25% S character. And 3 over 4 times 100 over 1 will give you what? 75% P character. That is why it is called sp3 hybridized orbital. Now I'm going to demonstrate how carbon could use its sp3 hybridized orbital to form 4 sigma bonds. Sigma bonds are single bonds. Now look at how it happens. This is